Equity and Inclusion Group for June 3. We have Andreas here to present to us on governing lake houses, I think. I forgot the title already. He submitted it to my user group, and then we never got him on our schedule, and then it became the next year. So I'm happy to have him present for this group. That way I can actually hear it. So that's a good thing. So he's got an upcoming appointment shortly after this, so I'm going to shut up and let him go. And how do you want to field questions? Do you want me to interrupt you, or do you have natural breaks,
Uh,
or?
I'm a super chaotic person, so number one, disclosure, I will not see people's hands or the chat. So if you have a question, unmute yourself, interrupt me wherever I am. I love the interaction, I love the flow, and it helps me to have a dialogue, right? Are we all cool with that?
That works for me. I've got it set so people can unmute themselves. So
Perfect.
everybody free flow and do what you need to do, and let's let him go ahead and present.
Sweet. So thank you very much for having me. So this session is called Governing Your Lakehouse with Microsoft Purview. And as I said before, please interrupt me if you have a question, if you want to say something, if there's something that doesn't make sense. It's, this is a safe space. Your opinions matter to me. Your questions matter to me, and there's no such thing as silly question. I am, well, let me do my intro. So my name is Andreas Bergstedt. I belong to the Azure Data and AI business in EMEA. And I belong to a team called the Global Black Belts. Now we are a pre-sales organization, so we are effectively the sort of the buffer between customers and program group and engineering within Microsoft. So we handle technical discussions or technical blockers for customer projects that are very specialized. We might handle things like architectural discussions, long-term vision, those kind of things. And also we handle roadmap discussions. So if customers want to understand what we're thinking long-term and where we're going, we sort of step in and facilitate those as well. And we do this to augment, obviously, what program group and engineering are doing on their own. They have wonderful speakers like Patrick LeBrock and them, Guy in a Cube, that do this professionally on a day-to-day basis. But we sort of sit there as an augmentation between that for very detailed, specialized discussions. Cool. With that out of the way, for today's agenda, I've got that broken up into 5 sections. They're a little bit obscured, but it all makes sense in the long run, or once I start going through them. So the first one section I called is the ever-scaling problem. And after that, we're going to go through why Lakehouse is becoming prominent and why it's meaningful. We're going to go over data and ownership. We're going to look at a section called operational performance. So this is about automation and sort of managing things effectively, and then automation and policies is more automation and managing some of the more sort of policy-based aspects of our data environment. And then we close out with a takeaway section and open Q&A, and you can ask me whatever you want. And again, stop me at any point in time, but I'm muting. I cannot see the chat, and just ask away. Cool. So let's look at the ever-scaling problem. So as we sort of move towards more cloud-native computing, and we sort of starting to look at building the correct sort of architecture for the cloud, we have seen, many patterns becoming more and more complex, and there's a lot of things to think about. Depending on what your architecture looks like, it might have different moving components to it, right? And they may take different shapes and forms, right? And then when you look at the entire sort of application landscape, or if we look at the the options of different compute resources, different storage medium, different modules, and that are out there for us to build our architectures with. One of the things that are very common between all of these is our data, right? And the data layer, funnily enough, has a very nice pattern, right? So if we think about standardizing our sort of our data lake or our data layers into a Delta Lake, so we have sort of standard patterns, that would sort of simplify this discussion. So with that in mind, I want to just quickly talk about why data lake, or why a lake house is becoming sort of prominent. So history lesson, we start looking at, well, not so much history lesson, but if we look at what data lakes sort of look like and what they were aimed at serving, there was always some challenge. Like we take the stab at a data lake and we say it serves a broad analytical use case. It facilitates different cohorts of users with different overlapping domains or areas, focus areas and projects, right? It is an open, free-for-all environment where we got a few principles that we sort of try to drive, vertical silos or principles. But data lakes had a bit of a flaw in them because they were too flexible. So you had these vertical silos like raw, cleansed, curated, model, clean room, sensitive, private, sandbox, blah, blah, blah. And they just sort of expanded. And then we sort of draw these lateral or concepts across them, like use cases or projects. And data lakes became a mess. It was hard to understand what was going on. There was no real standards in how you handled, interactions between these different silos, right? So Microsoft decided, well, we're going to give a stab at simplifying this. So a couple of years back, we came out with the modern data warehouse concept. And this was, at the sort of point where we established ourselves quite well with our Azure SQL data warehouse product, right? It was a good alternative to on-premises data warehouse appliances. In fact, the breed came from an on-premise data warehouse appliance, but it was built for the cloud. And we created this layer, this sort of storage layer in between in the modern data warehouse, where we would be able to facilitate also the sort of data sciencey workloads, the model workloads, being able to do very advanced analytics in Spark, because it was up and coming. Right? It was the trendy thing to do, but it wasn't great because we still had separate environments and it wasn't awesome. So then we try to modernize that in the sort of the 2000s when we came up with Synapse Analytics, and we sort of unified with the Synapse workspace, where you could have Spark workloads and data warehouse workloads, and we introduced the serverless workload as well. But this was, whilst it was popular, so to speak, and it was a good idea, it wasn't necessarily 100% practical, right? It still didn't solve the how do you solve your storage sort of environment. We try to start hunting more on the sort of adopting closer to the medallion architecture that Databricks had come up with. And that's ultimately where the Lakehouse went, right? The Lakehouse has become, the cornerstone of the Lakehouse is the medallion architecture, the way of handling, simplifying and collapsing the data lake into 3 specific layers or verticals. So we still have our bronze, right, or raw layer in bronze, where we accept that data is coming as is, no transformation. We just historize it and load it in date-based partitions. After that, we have a process where we convert the data into Delta, into our silver layer, And then in our silver layer, we standardize on storage format in terms of delta tables. But we also do minimal transformations. We do maybe some historization for SCDs, so we handle merging of data and updates on updated dates. We might do some data quality stuff, like make sure that our dates are formatted the same way, make sure that our whatever currency values hold, whatever it may be, or that we don't have any weird way of handling things, right? So very light data quality rules. And then our final layer is our gold layer. And gold is then where we have our business products or our data products. So this is where we serve our data. Everything has been, it's enterprise grade data models, be them star schema or dimensional data models, or be it tabulated, highly denormalized models for some data science project or whatever very specific sort of wide data table, right? Analytical table. So that's around the medallion architecture. So how would we implement this as a basic concept, or as a basic lakehouse architecture? So we would do something like this, where we have data factory ingestion into our raw layer, very cheap, very effective, good penetration from source systems, very simple to set up, and can be metadata driven, no problems, right? We then have a bronze layer. We have which is normal ADLS Gen 2 storage accounts. We run some Synapse Spark on top of that, or Databricks Spark if you want to run that. And the same for our silver layer to produce, go from silver to gold. Very simple. We then serve this up using our serverless Synapse serverless endpoints as a virtualized data model. So we have a SQL endpoint, and that is the typical sort of lakehouse thing, where we have our process running through Spark using metadata-driven frameworks. And then we have some compute layer that we put on top of compute endpoint to then serve up the storage layer. Now, obviously, Synapse Analytics in the Microsoft world is old, or is sort of getting an upgrade with Microsoft Fabric. So how we would see the lakehouse pattern in Azure today or going forward looks more akin to this picture. Where we have the one lake store or virtualized storage concept of one lake that would sort of serve this or facilitate the storage and data access. We run our Spark workloads or our data engineering workloads. Instead of our Synapse Spark, we have our ADX real-time engine. We have our data factory integration engine. And then obviously Power BI to serve up using our Lake Direct or Direct Lake Query. We also have a SQL endpoint where we can serve non-Power BI or for the non-Power BI visualization. So people like to run Excel or like to work in other products like Tableau or ClickView or whatever they may want to work in. They have the option to use the SQL endpoints, or if they want to consume the data models directly in the cold zone, because everything will be in Delta tables, so it should be open formats, right? Cool. Any question about lakehouse patterns, where we are today? Anything, any comments? Cool, awesome. So if we then move to the next section, so one of the things that have become really important in the last couple of years is data and ownership, right? So, and we see this with the advent of, well, when the sort of the cloud-based analytical estate came around, we saw an influx of domain-based thinking, or more sort of federated sort of data processing or data ownership models that came around, or operating models. Now, One of those very, very popular ones that got the most traction is obviously data mesh, and I'm pretty sure everyone that's listening to this call has seen or heard about data mesh at least. And if we go back about 2 years or so, we talked about 3 different data mesh concepts. It was fully governed. It was the so it was governed mesh. It was fully federated mesh, and in the middle we had a harmonized mesh, right? And there were quite simplistic takes on the data mesh concepts. They were, one was very rigid and defined ownership by central ownership, right? Or at least control and everything was centralized. The harmonized mesh meant that ownership was federated, but the processes were all centrally managed. And everyone used exactly the same patterns, based on a trust and understanding. And then there was the federated mesh where each domain or business unit could do whatever they wanted, and they would broker contracts between each other, right? So that was great in the beginning, but then over the last couple of years, this has grown legs a little bit. So we now have a few more different ways of seeing this. So not only is ownership or team independence and team ownership valid, but also clustering of teams is valid as a concept as well. So we got things like horizontal ownerships in the value chain mesh, where you have got some obscured clustering of team independence and dependence, right? And some of these models are really hard to articulate. Now, what's important about ownership, and in the context of today's call, I want to bring this through in terms of Purview. So when we're talking about defining ownership or defining structure for a federated or a domain-based architecture, and we look at the lakehouse, the one thing that we must do first is we must define our lakehouse in Purview. And I don't mean that like literally or physically define the lakehouse in Purview. I mean more like, what is our principles and how do they translate into Purview structure? So in this picture here, you have our the collection view of Microsoft Purview. And sorry, I'm just going to switch on my laser pointer. And as you can see, you have sort of a sort of environment filter first, right? And then underneath here, you've got some organizational structure. You have an engineering department, you have manufacturing, you have logistics. And underneath here, you can see our different lakehouse layers, right? So we have our bronze zone, our silver zone, our gold zone. And it's important that we define these things in Purview, because they will allow us to then establish data and control plane access in Purview, and to a certain degree also at endpoint. And we're going to talk a little bit about that in the end. And if you think about it this way, if you have a common pattern, right, like a lakehouse where you have bronze, silver, and gold, and your definition of gold is that all your data products and published artifacts must come from gold, then it makes sense that you split it up this way, because you can use this way of hiding all the engineering data behind, because your data analysts, when they're trawling or searching the catalog for a data set, they don't necessarily care about the data sitting in raw. They just care about what data is certified, what can I use now to solve my problem or start my project, right? So they ultimately, if you isolate it this way, you can publish or give the analysts access to your gold zones, right? And that means that you can control how they see or their search experience and their interaction with the Purview data catalog, right? The other thing that is really important about this is that it determines control and ownership, right? So the data owner or the data owners associated with engineering, for instance, and the various zones are readily defined in Purview. So you don't have to guess. You can automatically understand, which team is impacted, of a change, in lineage. Who should I speak to if I need a new data set from this team, and that sort of thing. So, and also who's accountable, who's responsible. So this help, the collections allow you to naturally determine ownership. And also it's doing it this way helps you to establish common process patterns. For instance, if we onboard data and you structure it this way, you can have a common way of handling things in your bronze layer. You can create a pattern rule that says anytime I scan data in my bronze zone, this is how I handle my naming conventions for these, or for these type of data sources. So if it's an API data source, I handle naming convention in one way from a relational database source, right? So there are ways of by breaking it down into this, you can create like common process patterns that will help you scale as your data state grows, right? And then the last one is it also helps you to easily define and determine scope for policies and workflows, right? And this is important when you're doing things like your curation approval workflows or your self-service data access workflows. This becomes really important that you've structured it in a pattern that follows how you process data and how data is owned. And then, sorry, I forgot, there's one more, and that is that obviously it enables self-service data democratization, right? And it supports and facilitates data literacy in the fact that you're able to, because we structure the catalog the same way our data processes and data ingestion is structured. We obviously, it's natural, we all speak sort of similar languages, right? Cool. So I've got a few slides on what I call operational performance. So this is more around accountability, and I start off with one of these pictures. So if you look at how different data governance bodies can work together, as you look at how data products gets governed with application owners and stewards and engineers, or data domains with data owners and the business users there, right? So if we can understand the relationship and sort of at an enterprise level articulate this well, that means that we can establish accountability in the business really well. And that we can do this by using concepts like the meta models in Purview. So our business assets, right? Now, these are things like a business application, a business process, a data product, right? And then if we encourage business to practice good stewardship, so in other words, we're going to invest in a policy around how we release or document a process, or how we release a business application, right, or a data product. And we say definition of done is always, have I updated my lineage, my data asset lineage in terms of ownership, in terms of data product lineage, data artifact lineage. Like, have I done the things? Like, do I practice good stewardship when I release something and make sure that everything is clean from the get-go in the catalog? Then that just helps you get more accountability. And then the other one is also try to use native capabilities to enable this visibility. Because imagine imagine my business process is well defined, and I have my business process in the meta models have related data sets. That means that we bridge the gap and we get end-to-end visibility from a business process all the way down to a data artifact, be it an entity, a report, whatever it may be. But it helps us to become more operationally efficient in terms of doing impact analysis, controlling changes, and traceability back to a process or ownership. Cool. The last purview section I want to talk around is automation and policy. So I want to just highlight that we have a very structured way in Purview of handling self-service data access requests. And what you're seeing here is a data access request workflow, right? And you can see that it's very simplistic. We start with a request. Now, imagine this is scoped down to the correct gold zone for business units. So we've defined the data ownership there. We can make sure that the approval request is sent to the correct data owner for those data sets. Once the request is approved, we can then do endpoint enforcement. So if this is an ADLS Gen 2 dataset, like a data lake artifact or like a delta table, whatever it may be, we can automatically approve access. We can also make custom. So if it's not managed, right, we could call a REST endpoint that we can engineer using common patterns, right? So this example is where we're triggering a data factory REST endpoint or data factory job or pipeline, and we're passing in the data assets fully qualified name as well as the requesting user, so who needs access to it. And then we can do all the sort of plumbing underneath. And then also the last one, once that's done, we also have the ability to run the similar kind of job to stand up plumbing that's required. Cool. The other thing, which is also important, is to use some of the automation workflow for managing glossaries, right? So make sure that you've set up approval workflows on how glossary terms are updated, and also equally important how you handle updates to your actual data entities. Sorry, Tracy, I think your mic is you're tapping away. It's coming through on the mic. Thank you. So it's important to use these workflows and develop them, because they will help you at scale, especially if you're structured. You follow the collection structure to mimic your lakehouse. That means that all of these approval workflows, because data ownership is known, everything is going to be programmatic and work at scale. And then lastly, so what are the key takeaways? So very simple, the data landscape is expanding, and so the business needs. We see that in the tech stack, it's getting bigger, and we're seeing that more sort of federated patterns emerging. We're seeing that standardizing patterns help IT, but we must remember that governance is team sport. In other words, all your data owners or the business users and everyone else needs to play ball and see it as a team sport, and then building data governance control into engineering practices. will help you ensure that data governance become part of your rhythm. And this is, like I said, when you release an API or whatever you release, you might have it as part of your definition of done, that whomever the technical person is or engineering resources, that they have done the last little checks and balances in the data catalog in terms of curating whatever asset they were working with. And then last one, leverage automation and remove dependencies on central teams, right? So by automating, IT becomes less busy and can actually focus on what's important to them, rather than having to worry about data access requests and that sort of thing. Cool. And with that, I am a little bit early, and it's Q&A time if required.
Sorry about
I
the
have I have a question I'd like to ask.
Yeah,
Let's say
go
if
for
you're
it.
in an organization and they have no data governance at all, where's the best place to start? You're not going to dive right into the middle of a giant chart. But where do you begin when you have nothing and you want to get here? Where's the right place to begin?
So the right place to begin is to start writing some policies. Coming up with actually tech is not the answer here, and that is the important thing. So let's say you're a small organization, and what you need to understand why you're doing this, right? So data governance is or has traditionally been like a reaction to, oh, there's some big, atrocious compliance requirement from our government that I need to conform to, like GDPR, right? Or Safe Harbor or POPIA in South Africa, whatever it may be, right? So something that you need to comply with, or else big bad things are happening. That's normally what happens. So the first thing is coming up with a definition of data ownership. So who owns the data, right? Coming up with a definition of what needs to be curated, because we often look at data governance, especially around like curation and data stewardship, that data governance is a big, massive event that's going to happen because I'm going to scan my entire estate. I'm going to get a whole bunch of technical metadata. It's going to have to be restructured and organized, but it's literally understanding how I care about ownership, how I'm going to handle curation, what data needs to be curated, right? And what needs to be published. So it's like start with those like basic business questions, like what is my intent and why am I doing this? Because that will sort of set the tone. If your need is to, I want to run an inventory of my data state so that I can automatically tag sensitive information, right? If that is your only need, then yeah, just deploy scan and you have your inventory, right? And hopefully the automatic classifying engine will tag all your data correctly and it doesn't need curation. But if your intent is, I want to practice good governance because I want to be able to leverage things like doing impact analysis, understanding more than just technical definitions, then you have to come up with these things. Like, how do I see, where do I start? Like, what is important to the business? Don't see what's important to tech. There are a couple of really good resources out there. So I'm going to butcher this one up. There's an acronym. The Cloud Enterprise Data Management Consortium, I'm sure it is CMDC. They are really good. They've got some good guidelines that are freely available. You don't have to pay them for any consulting time. But they've got some good guidelines in terms of where do you start and how do you think about data governance. Cool. Does that answer your question, Edward?
Oh yeah, thank you very much. That was great.
Cool. So, any other questions, anyone? No? Cool. Any comments? Was this useful besides getting the last question? Cool. I think Tracy. I think that's it. It was a small and personal audience, but all good.
Yeah. Sorry, our group's still growing, like I said, so we're getting there. But thank you for presenting, and
Cool.
I appreciate it, and we got you done in time for your next thing that you needed to do. So hopefully it'll keep the stress levels down for you.
Perfect.
And hopefully we'll have you back sometime, and maybe next year for my local user group, we can have you present virtually. So
Sure. Anytime. I'm happy to support the community.
yeah. I'll talk to you another time. Thank you very much.
Cool. Thank you very much, guys. Have a good one.
Thank you.
You too.
Okay.
Bye.
Thanks.